Good afternoon, this is Schweitzer, and we're moving on to our next topic. And it says, okay, how do we know that H3O plus ions are going to be what makes something acidic? And we do know the concentration of this guy versus the concentration of the hydroxide ions is what makes something either acidic or basic or neutral. So the question is okay, we have all of these acids. And just about everybody could probably rattle off an acid or two that they know through their life. For example, we can have HCl, which is hydrochloric acid. Or we could have vinegar, which is HC2H3O2. Vinegar, or otherwise known as acetic acid. So I'm saying that regardless of the acid, hydrofluoric acid, all of them in the end produce the same chemical, H3O plus ions. So in this situation, how does this work? Well, it turns out that, and that's our first question I have listed there, okay, is that every single acid follows the exact same chemical reaction to produce these guys. And it's called the hydrolysis equation. The hydrolysis equation essentially is where an acid, I'm going to call sometimes it's just HX, will react with water, which is in the solution. You might remember earlier on in naming acids, we always put it in water because this water is a critical piece of it. And then it donates in H+, and that fooled people for quite a long time. They thought the H+ was the end product. Turns out that's not H+, it is going to be H3O+. And they stuck with H+ for so long that these guys, H+ and H3O+, are synonymous for the same thing. This means H3O+, every time, every single time. And if HX gives up an H+, that means X negative is what's left over. And this simple chemical reaction is what we deem to be called a hydrolysis equation. Okay? Now, although not as important, okay, and meaning that for usefulness of doing things, there is a couple of key ideas here, but this formula, writing this formula out, is going to be absolutely critical. Okay, writing this chemical reaction out. We'll use it all of the time. So if I want to write out, and it's the same every time, but if I had a buck for every time I wrote this out through the school year, you know, I would have a couple $100 because we use it that much. So let's practice writing the hydrolysis equation for the acids I mentioned above. First of all, we have HCl. And it ends up being quite simple. H2O yields. Now I'm going to allow HCl to donate in H+. So this is going to donate in H+. And the water is going to accept the H+. This is going to give us H3O+ and Cl-. Next one, vinegar. HC2H3O2 plus H2O yields H3O plus C2H3O2-. And then we have HF plus H2O yields H3O plus F negative. So you'll see the template's not a whole lot different from what we typically have. Now, one concept would be to write the formula. The other concept to understand, I think, is maybe second most important on this video, is that if an item, okay, let's just say this, we'll call an acid. Okay, what makes something acidic? Generally speaking, it contains this H+. Okay, and it's going to donate this H+. Well, once it gets rid of it, gives it to somebody else, then this item is it an acid anymore? I don't think so. I mean, the fact that it's an acid is because it has the H+, but once it gives it away to somebody else, then it's no longer an acid. So we call this, in fact, an acid is something that can donate an H+, and a base is something that can accept a hydroxide. And we call this, this substance is the, is the same substance really, it's just minus the H+. So we call this now the conjugate. It's no different than, let's say we have a basketball court going here, basketball game going, okay, and you have a guy who has the basketball, right? And you have a guy who doesn't have the basketball. Well, once this guy throws the ball to this guy, all right, now this guy doesn't have it anymore, or an arm. There we go. So before this guy had the ball, now this guy's got the ball. Whoever's got the ball is considered the acid. This guy is now the conjugate base. But before he was the acid, and now this guy was the conjugate base. So whoever has the basketball at that moment is considered the acid. Whoever doesn't have it is considered the conjugate base. And really the basketball player is not a whole lot different. It's just the basketball before player, mainly the same guy. Either he has the ball, now he's the acid. He doesn't have the ball, now he's the base. So more important than to understand the acids donate or acids accept, more important is to understand that if you have an acid, HX, and it donates or gets rid of its H+ ion, leaving it as its conjugate X negative, this is acidic and this would be basic. It flips from one to the other as it loses its H+ ion. That is more useful, okay? So with that being said, we'd want to go through all of these formulas and be able to label who is the acid, who is the base. So in this situation, we say, okay, well, I have HCl, which is going to be donating to the water, so this is an acid. The water is accepting, so it's called a base. But now, very often, we would connect up with lines the conjugates. And the conjugate's the same, it's like the basketball player. It's the same guy, it's just minus an H+. So it's very easy to connect these because they look almost identical. So this is acid, and therefore we flip it, we call it the conjugate base. And this is called the conjugate acid. It just flips base, acid base. And we call these, the lines, hook up what we call it an acid-base conjugate pair. The next one, I'll just circle, I'll connect with lines the conjugate acid-base conjugate pairs. This guy is an acid-base conjugate pair, and this guy acid-base conjugate pair. This is the acid, this is the base. This is the, it flips, conjugate acid, conjugate base. Note that our main deal here, that guy, always has to be the acid. So this is the conjugates, and these are the conjugates. Acid, base, conjugate acid, conjugate base. Another example, okay? Let's say we have this substance, NH4+. Alright, you wouldn't know if this thing is going to donate an H+ or accept an H+. I mean, you don't really know much about ammonium, but in this case, ammonium is going to act like an acid. It is we call a weak acid, but it doesn't make a difference. It's an acid. It's going to donate H+. Normally our H+s are out front, This one, it just puts it on the back. And it can only donate one H. Some acids can donate multiple H's. So let's write it out. If NH4 plus can react with water, it's going to produce, well, let's see. What's going to be my products? It's going to donate an H plus to the water, which forms H3O plus. Well, if NH4 plus donates an H plus, what's left over? NH3 with no charge. This is the acid, and its conjugate is NH3. This is an acid. This is called the conjugate base. This is the base. This is the conjugate acid. So NH4 plus, which is commonly referred to as ammonium, and we have NH3, which is ammonia, are very common players in acid-base world and in our everyday lives. So this is commonly referred to as being acidic, and this is basic. And it's used for all sorts of things involving biological formulas, pathways, cleaners, chemical reactions, lots of stuff. Alright, so a couple of concepts here. One, how does an acid produce H plus ions? The answer is hydrolysis. And the second piece of this is, can you label the acid-base conjugate pairs of a chemical reaction, which is emphasized, more importantly, that acid-base conjugate pairs flip from acid to base as they go through hydrolysis. All right, thank you.